Okay, reaction with carbonates and hydrogen carbonates. Alright, now this is not only applicable to nitric acid but any acid. Okay, it may be sulfuric acid, hydrochloric acid, or even in fact for organic acids also. Okay, any carbonate or hydrogen carbonate with any acid, whether it's a mineral acid or an organic acid, is always going to produce its respective salt plus water, and there is going to be effervescence of carbon dioxide gas. Okay, effervescence of carbon dioxide gas means sound like soda will be produced if you open a soda bottle. Okay, you can see how carbon dioxide gas is evolving. So in this way the reaction is going to take place with either carbonate or hydrogen carbonate or bicarbonate. Okay, so the first example over here is sodium carbonate. So obviously the respective salt that is produced over here. Okay, so Na will go with NO3, so that's going to become sodium nitrate, that's NaNO3, plus water plus carbon dioxide, that's CO2. Okay, here you can see Na is 2, so I can multiply these with 2. Okay, I just have to multiply these with 2 and the equation is balanced. Okay, similarly here in the second part we are having lead going with nitrate, so that's going to give us lead nitrate. The formula of lead nitrate will be Pb bracket NO3 twice, then H2O, and then again CO2. Okay, this is twice and 2 hydrogens, so I just have to multiply these with 2. The next equation is very similar to the equation just we did right now. Okay, instead of Pb you are going to put Cu, so copper nitrate will be CuNO3 twice plus H2O plus CO2. Okay, I just have to multiply these with 2. Just put down these equations. Now reaction of nitric acid with metals. Okay, now nitric acid is not a regular acid, it behaves like a typical acid. Otherwise normally any metal with an acid should give its respective salt and hydrogen gas. Okay, but nitric acid only in certain conditions shows this kind of behavior. Okay, that is with metals like magnesium and manganese, only if you are having 1% of these acids, then it behaves like a regular acid, giving you its respective salt, that is its nitrates and hydrogen gas. Okay, the reason for that is because nitric acid is a strong oxidizing agent, so the hydrogen that is produced over here, okay, that is being oxidized to water, and in the process nitric acid itself gets reduced to nitrogen dioxide. Okay, so these are the only 2 equations in which it behaves like a regular acid to produce its nitrate, salt and hydrogen. So you can just put these 2 equations. Magnesium with its nitrate part will give you magnesium nitrate, whose formula will be MgNO3 twice it is, and hydrogen gas. Similarly here manganese nitrate will be MnNO3 bracket twice and hydrogen gas. Okay, the balancing of these equations is very simple, you just have to put 2 and 2. Just put down these equations. Next part is reaction with metallic sulfides. Now this reaction is very similar to that of carbonates. Only thing is here S is replaced with C. So if you are having Na2CO3, it becomes sodium carbonate. If you are having Na2SO3, then it becomes its sulfide, that's sodium sulfide. Okay, so the reaction is very similar. There we were getting the gas carbon dioxide, here we are getting the gas sulfur dioxide. Okay, so wherever C is there, that will be replaced with S. So you can just put down these reactions. So this is going to give sodium nitrate, that is NaNO3, sulfur dioxide is SO2, and water, that is H2O. Okay, calcium sulfide will give you calcium nitrate, that's CaNO3 twice, and sulfur dioxide, that is SO2, and then H2O. Okay, the first equation you have to put 2 over here and 2 over here. Okay, for the second equation you just have to put this 2 over here. Okay, you can just put down these equations. Now, oxidizing properties of nitric acid. Okay, because nitric acid liberates nascent oxygen, therefore it's a very strong oxidizing agent. We are going to see the oxidizing property of nitric acid with various other substances. So this is going to produce water, that is H2O, nitrogen dioxide, that is NO2, and we are having here nascent oxygen. Okay, so you can just put this 2 over here. There are 6 oxygen atoms, okay, which are getting balanced. So nascent oxygen can be written in the brackets. Okay, now this nascent oxygen is responsible for oxidizing other substances. Okay, we'll just come down and write these equations. Okay, the first reaction is reaction with carbon. Okay, so carbon obviously will get oxidized to carbon dioxide, which is over here, and in the process nitric acid itself will get reduced to nitrogen dioxide, so that is going to produce NO2, and the other product is water, that is H2O. Okay, we can start balancing these equation. You can see your hydrogen here is only 1. Okay, this is 2, so I can multiply these with 2. Okay, but you can see this leaves oxygen here an odd number, so I'll have to multiply these with 2, which is going to make ultimately 4 hydrogen. So this makes also 4 nitrogen then, so I'll have to multiply these with 4. You can count the remaining other atoms. Okay, hydrogen, nitrogen is balanced. Oxygen is 4 into 3, that's 12. Here we are having 2 oxygen. Here we are having 8 oxygen, and again here 2, so this will add up to 12 carbon. There is only 1 carbon atom. Okay, so this is the balanced equation. Now sulfur similarly is getting oxidized here to sulfuric acid. Okay, so that's going to become H2SO4, and here nitrogen dioxide, that's the reduced product, okay, along with water, that is H2O. So the balancing will be similar here. This is an odd number, so I'll multiply these with 2. Okay, this is going to make how many hydrogen atoms? This is 2 2s are 4 plus 2, that's 6. So in order to make this 6 hydrogen atom, I'll multiply these by 6. Okay, so this will make 6 nitrogen, so I'll have to multiply these with 6. Okay, we can count now other atoms. Sulfur here is only 1. Okay, hydrogen is already balanced. You have to check for oxygen. Here oxygen is 6 into 3, that is 18. On the right side we have 2 over here, we have 4 over here oxygen atoms, and then 6 2s are 12. 12 plus 4 is 16, plus 2 18, and this is 6 3s are 18. Okay, you can just put down these equations.